Hello everyone and welcome to the Convert channel. How can we actually calculate outlet pressure of this piping system which actually liquid water passes through the 1000 meter of 6-inch tube, then it goes uh, vertically up a meter, and we will use the Hysys software and calculate outlet pressure of this piping system. You will also learn how to fix the problem of actually 10% increment within the software Hysys. The information for the water liquid is provided here. 20 degrees C, 3 bar is the inlet pressure, and 100 cubic meter per hour is the flow rate. So let's jump into the simulation area. I have provided this information within this uh, actually flow, as you can watch, and I have inserted NRTL as the proper fluid packages. So go to the piping and hydraulic, then add and drag the pipe segment into the simulation area. Then you need the inlet stream and outlet stream is the water outlet. So make sure that you have defined the energy stream as well. So go to the rating tab. Under the rating tab, just make sure that you have actually uh, inserted the outlet temperature as well. So we need to consider 20 degrees C, which the whole system is within a constant temperature. So go to the rating tab on the append segment, insert the first append segment. So as you can see within the configuration, we have 1000 meter of 6-inch of the pipe. So insert 1000 as the length in meter unit, and elevation change is 0. Outer diameter is 6-inch. So let's consider 150 millimeter as the inner diameter of the pipe segment. So how can we fix this problem? Increment actually differential pressure is not converging. So what it means in the software, actually it used numerical method. It cannot converge because it's divided each section of the tube, and then solve the problem for each section separately. So we need to increase the increment to make sure that all the actually required criteria is going to passed within the range, actually falls within the range of the Hysys as previously defined. So inserted into the 10 segment, as you can see, we have converging this segment. So how can we add a 10 meter of the pipe that goes vertically up? So let's go to simulation again and append segment, another segment as well. So we have 10 meter of the pipe, that elevation change is 10 meter as well, and the outer diameter is the same as the first one, is the inner diameter is 150 millimeter as well. So we have the same problem as well. So as we know, it uses a numerical method to separate the pipe segment into many different segments. So we need to increase the increment to make sure that all the actually required criteria falls within the range that have previously defined within the Hysys software. So I'm going to change it into, for example, 10 increment. As you can see, it not converge. So let's increase it again. You can see we have successfully converging this pipe segment. So we have the outlet pressure of the 0.5. As you can see, we have all the information, and we can watch the information just right here, and within a constant temperature of 100 cubic meter per hour for the 3 bar water that is within the liquid state, the inlet pressure is 3, and as it passes through this pipe system, which is drawn right here, 1,000 meter horizontally and 10 meter vertically, we have the outlet pressure of 0.5 bar. So if you found this tutorial helpful, please subscribe my channel and share it with your friends. Thank you. Have a good time. Bye bye.